Dear students, having discussed Harrod and Domar model in detail, it is now time to compare the similarities and differences between Harrod Domar growth model. As I told you earlier, it is the similarities between the central results of the growth models of Harrod and Domar that resulted in the name, the title Harrod Domar growth model, even though Harrod and Domar separately developed their growth models. Now we compare these growth models. Now, as we have discussed earlier, Harrod's steady state equilibrium growth is given as EA is equal to GW. Steady state equilibrium growth requires that GA is equal to GW or GA is equal to S by VR. S by VR. And in the Domar's model, dynamic equilibrium requires delta I by I as equal to S into sigma, equating the demand side and the supply side of the model. We have dynamic equilibrium in the Domar model as delta I by I is equal to S sigma. Now, what is sigma? Sigma is defined as the potential increase in output per unit of investment. Potential increase in output per unit of investment. It was denoted as delta Y by I or delta Y by delta K or simply delta Y by I. Potential increase in output per unit of investment. And what is VR? Now, VR is the number of units of new investment required to produce the extra unit of output. Number of units of new investment required to produce new level of output. That is, VR is equal to I by delta Y. And sigma and VR assume that new investment is properly utilized. While discussing the Harrod Domar model, for deriving the warranted growth rate, the required growth rate, we assumed that the capacity is fully utilized. We also assumed that the capital output ratio and also the incremental capital output ratio is same. So both the sigma and VR assume that investment is properly utilized. So it is clear that sigma is equal to 1 by V or 1 by VR. sigma is equal to 1 by VR. So we have the condition for equilibrium growth as sigma is 1 by VR, we can write it as S into sigma. S into sigma. S into sigma. So sigma is equal to 1 by V or 1 by VR, and you will get the same equilibrium growth condition in the Harrod model and also in the Domar model. Or what we say is the equilibrium rate of growth in the Domar model is identical to the warranted growth rate in the Harrod model. Both are one and the same thing. But a perplexity arises here. The perplexity is Harrod equilibrium at a full employment require that GW is equal to GN. In the Harrod model, equilibrium growth rate, steady state growth rate with the full employment require that warranted growth rate is equal to natural growth rate. But in the Domar model, Domar in his model make it clear that S sigma, that is S sigma to him is equilibrium rate of growth that ensures maintenance of full employment without any reference to rate of growth of labor force. So in the Domar model, Domar assumes that or suggested that S sigma ensures full employment growth rate which is equal to S sigma ensures full employment without reference to the rate of growth of labor force. Or stated differently, in the Domar model, there is no mention about natural growth rate, which is delta L by L is equal to N. And Domar, as we have discussed, make no assumption concerning the rate of growth of labor force because GN is missing in his model, and it is difficult to be certain about the exact relationship between GW and GN in the Domar's model of economic growth. As Domar did not specify GN, if the economy is growing at S sigma, whether it means only full employment of capital or whether it means full employment of both the capital and labor is not clear in the Domar growth model. And this is a problem which we encounter in the Domar model when we compare Domar model with the Harrod model. But a solution is suggested by Harrod. According to Harrod, in the all-encompassing nature of Domar's definition of potential social average investment productivity, which seems to imply that S sigma incorporates both GW and GN. Harrod see the resolution of the difficulty by suggesting that in the Domar's definition of potential social average investment productivity, which seems to imply that this S sigma includes both GW and GL. In his definition of potential social average productivity, S sigma includes both GW and GL. Specifically, Domar assumes that sigma normally lie between sigma bar. Sigma normally lie below sigma bar, where sigma bar is defined as the absolute maximum potential average investment productivity, or it is the maximum productivity of investments. And Domar suggested that actual productivity of investments typically lie below potential productivity of investments. Now, what is the reason? The reason suggested by Domar is that there is what is known as a shortage of other factors of production in the long run growth process. And if this is true, then Harrod's interpretation that S sigma corresponds to his natural rate simply because sigma is constrained from equality with the sigma bar by the growth of labor force. So, sigma is typically below sigma bar, potential average investment productivity, due to shortage of other factors. So, Harrod's interpretation is S sigma corresponds to his natural rate simply because sigma is constrained from equality of sigma bar by the growth of labor force. The point is, in the Harrod model, equilibrium growth rate requires GW equal to GN. If GN is equal to GW, then both will be equal to S sigma. But if GN is less than GW, then sigma will be less than sigma bar productivity. So that means S sigma corresponds to the natural rate, and the requirement is that S sigma will be equal to what is known as, or sigma will be equal to sigma bar if and only if GN is equal to GW. So in the words of Harrod, if only there is enough labor, etc., the economy could grow as S sigma bar. If only there is enough labor, etc., the economy could grow as S sigma bar, which is really my warranted rate. But the lack of labor, etc., compresses potential growth to S sigma, which is my natural rate. If there is no shortage of labor, etc., economy will grow at S sigma bar. That is the natural rate. That is the warranted rate. If there is constraint of labor, etc., economy will grow at S sigma only. That is the natural rate. That is, if natural rate is lower than warranted rate, economy will not be able to grow at a natural rate. Economy will be able to grow only at a warranted rate, which will be less than natural rate. In such an economy, there will be continuous unemployment. Unemployment will become a severe problem. So, we can say that Domar's definition of S sigma encompasses both GW and GN. Growth at GW if there is no constraint of labor. If there is constraint, then only a sigma at a warranted point. But so even though we can resolve this issue, there is, however, fundamental differences between Harrod and Domar growth models. One fundamental difference is in the Domar model, there is no investment function. There is no independent investment function. In the Domar model, there is no independent investment function. His equilibrium growth rate is the rate that ensures continuing equality between actual and potential income, that we have defined as delta yp is equal to delta yr. Continuing equality between delta yp and delta yr, but actual level of investment is not determined within the model. Stated differently, Domar's approach is one of deriving the dynamic consistency conditions required for equilibrium growth rather than generating a theory of growth. So, in the Domar model, we specify the condition for equilibrium growth, but it is not a theory of economic growth. But in the Harrod model, there is a specific investment function in the form of a simple acceleration mechanism that we have discussed in the context of warranted growth rate. That is a fundamental difference between Harrod and the Domar model. In the Domar model, there is a specific investment function. In the Domar model, there is no specific investment function. Now, to summarize the similarities between Harrod and Domar models, let us see what are the similarities. Both models begin with the fundamental Keynesian concept of equilibrium. Both models starts with the condition required for equilibrium in a Keynesian type economy, but rather than examining the short run equilibrium as y is equal to c plus I, aggregate supply is equal to aggregate demand, they move to long run, eschewing the Keynesian assumption that rate of investment did not increase the size of capital stock. In the Keynesian model, investment is considered to have only the demand effect. That is, aggregate demand will increase. But in the Keynesian model, the effect of investment on capital stock and hence the productive capacity of the economy is not discussed because Keynesian analysis is short run. But in the Harrod Domar model, this potential effect on productivity resulting from investment is discussed. In the Domar model, as we have seen, investment has a dual effect. It increases aggregate demand, it also increases the productive capacity. That is one similarity. The second one is both models generate equilibrium conditions implying constant proportional growth rate of output. In the Harrod model, it is delta y by y is equal to S by VR. In the Domar model, it is equal to S into sigma. And as we have discussed, both are one and the same thing. A third similarity is both models analyze the difficulties of attaining long-run equilibrium growth with the full employment. And as we have seen, in the Harrod model, there is no mechanism to ensure that GW is equal to GM. In the Harrod model, there is no mechanism to ensure that GW is equal to GM. And also that GW is inherently unstable, characterized by what is known as knife edge property. And in the Domar model, delta I by I need not be equal to S into sigma. This is only an equilibrium condition. It is not necessary that it will be the case always. So both models discusses the difficulties of attaining long-run equilibrium growth rate. And in both models, it is assumed that capital output ratio is a constant, and delta k by delta y, or y by k, or delta y by delta k is a constant. And in the Domar model, it is due to fixity of technology, and in the Harrod model, it is due to the fixity of factor prices. Anyway, both the models are based on constancy of capital output ratio. And finally, both the models discusses elements of instability, and it is more clear in the Harrod model rather than in the Domar model. The reason is Harrod explains clearly three growth rates and condition for stable growth at a natural and warranted rate. But in the Domar model, only the condition for dynamic stability in a growing economy is specified. And these are the similarities between Harrod and Domar growth models, and also the dissimilarities.